All right. Welcome, everyone. And I'm super happy to be here today and be able to talk to you about speed up incremental compilation with NX. But before we start, let me quickly introduce myself. My name is Juri Strumpflohner. I'm from the very northern part of Italy. I'm a Google developer expert in web technologies and Angular. I'm also an instructor at Egghead.io and Cypress ambassador. Currently, I work at Nrwl as a JavaScript architect and engineering manager. And as you probably know already, Nrwl has been founded by Victor Safkin and Jeff Gross, now already, I think like 4 years ago already. And what we try to do there, or what we do, is basically help your team learn, grow, and be successful. And we do that in a variety of ways. So first of all, we help you plan your priorities, lay out the roadmap, and especially help identify potential technical constraints that might hinder you achieving your end goal. And what we also do, obviously, is to do training. We do that in forms of workshops, which we hold online or on-site. We talk at conferences like this one today. But anyhow, the preferred way of collaboration for us is definitely to be embedded and part of your team. Because obviously that's where we actually see the daily problems as they come up. We can help you coach you specifically on those problems and basically have an ongoing training and collaboration as the project progresses. So today I would like to mostly talk about NX. NX is our open source dev tools for Monorepo, and you can actually check it out on nx.dev or directly on GitHub. So let's talk about speed. Now, we at Nrwl are strong believers in monorepos, and that's for a couple of different reasons. Like, first of all, we obviously believe that it helps you ship code much faster. That's because you can share code more easily. You have everything like in one repository, and you can build things there much more efficiently and identify issues much earlier than you would in a more distributed fashion. But there are downsides as well, of course, and that's where tooling comes into place, and that's where like NX comes into place. So normally what an approach could be is that you start with an application in NX, and in NX you have basically apps and libs. That's the main structure, like that's the building block. And you basically, as you develop and you continue, you might even like identify that that single application could be split up into multiple ones, which will again help you scale in the long term, because now you have like two different applications which can be deployed in a different scaling environment. You can like scale up the public one much more than maybe the more back office administration part of your application. And you can already see how those applications simply reference the libraries where most of the part of the code actually lives. And as you continue in a monorepo, you might even add other technologies, like not just Angular, but you might also add backend technologies, ideally, for instance, like Nest.js applications or plain Node Express apps. And they should be able to share code with your front end. You might even add a React front end or some other type of front end technology there. But obviously, as things continue, you don't always want to like build, test, lint everything. Like if you develop a new feature and you create a new PR on your CI pipeline, then you don't want to run the build of all the various projects which you might have in your monorepo. Because like initially, when you have just one or two apps, it might even work. But as like your applications grow and you have like much more and more libraries, which could even go into hundreds of libraries, then you can imagine that this would simply not scale. So for instance, a naive run here, which is visualized by this timeline here, you can see like that one project follows after the other. So the different colors represent different projects that have to be built. And obviously the time you have to spend on CI in this scenario is basically the total time of all the projects being built one after the other. And so what happens usually in the development? So you have your Git repository where you have like your master or main, which is the main branch. Basically, people then, your developers, pick out features or fixes for like potential issues that you have. And so they're developing their feature branches, which they then submit up into the CI pipeline, usually via some PR. And as things continue, then the CI pipeline picks out those PRs. It runs the building, testing, linting, whatever you actually execute on your CI pipeline. And once that like passes, it gets merged in back into master. And so this basically guarantees the health of your development cycle and the quality of the code that ends up in master. Now you can imagine as we continue and as more developers work on your repository, that queue on the CI pipeline might soon become the bottleneck, because like what happens there is you basically have also like reviewing process going on. So you might have to do changes. You might have to update your PR based on the latest change that happened in master, and so do a rebasing basically. And so this is clearly the potential bottleneck as we continue, because like if that PR, like if a single PR can only be processed like in an hour or even more by your CI server, then obviously you can only get that much into your master branch in a given day. And so NX helps there with the so-called affected commands. And I also kind of always or often call them like NX knows what you're actually building. So why is that? Well, basically behind the scenes, NX has the so-called dependency graph. And in that small terminal there on the slide, you can actually see how you can invoke that. And you can basically at any point run NX dep graph, which will visualize you this dependency graph, which is the current representation of the relations between your apps and libraries, and even between libraries themselves. And now this is obviously super powerful, because it's not something you like create as part of your documentation. And we all know that as we create those diagrams, they are often already out of date, or they don't reflect actual truth. Since this is being like read out of your current source code state, this is always up to date. But moreover, there's an important thing here. This dependency graph is not just for visualization purposes, but it's actually being used by NX in order to optimize certain commands. And so, for instance, there is the so-called affected dependency graph, or the affected commands in general, which allows you to identify only what changed in a given feature request. So imagine like your developer creates a PR, it changes a couple of libraries, and then it pushes them up as a PR basically on your CI server. If you use those affected commands, NX can actually read those commits that have been made, compare them to the baseline, which is usually like master or main, and then identify based on those commits which projects have been touched. So in this case, for instance, we can see that just those three basically are affected, and so they have been basically modified. And all the other projects in this entire graph basically can be left untouched. And so we don't even have to execute the testing, linting, whatever on all those projects. And you can imagine like this drastically already improves the speed, because now only those three have to be touched and treated. And you can use those affected commands basically with that NX affected : and then the target you want to execute, which could be test, building, or even targets you define by your own. And so if you compare that again now to the main naive approach which we had initially, we can already see that we can cut down the times quite a lot. Obviously, this depends on the change you make and how many libraries you actually touch. But like this could be a good average which we actually observe with our clients. We can even go ahead. And what we can do is we can parallelize work. So basically, we can again take that NX affected command, but now we pass in the -- parallel, or -- max parallel equals 4. And what that does is basically just like spawn different threads that run the different kind of test runs. So in this case, we are executing tests. And so this would basically divide them up into equal batches and run them into different processes. And the max parallel actually tells NX like how many of those should be instantiated. And that's mostly for limiting basically the capacity you have on your machine or on your CI server. You can even go further. You can not only just parallelize, but we can also distribute them across different nodes. So in this screenshot here, you can see like an actual run on GitLab, where basically the tests are not only parallelized within each node, but they're also distributed among different kind of machines, in this case, 8 different machines. And so you can imagine this already speeds up things a lot. And if you're interested in distributing your CI pipeline, then there's a link on this slide on the very lower right, which you can like click on. And we have a couple of example configurations there to get you started and like continue and set it up for your own build. And so again, if we now take this into account, then the longest, like your total CI time basically is equal to the slowest part, right? Because now we run them in parallel and no more in sequence. And therefore the slowest one determines the total time you need to run on your CI. But you already can see a lot of improvements. Another thing I'm super excited about is the actual computation caching. So what computation caching does, this is something on top basically of the affected command. And what happens there is that if you execute nx run, for instance, shop cart feature, which could be like one library, and the tests on top of that library. What nx does in this case, it takes the source files into account. It also takes like the config files, which you might have some runtime inputs, which you can even define on your own, like environment variables. And then it verifies whether that command against those different artifacts has already been executed before. If it has not been executed, it actually executes the command. Like in this case, it runs a couple of jest tests and then stores the result in a local cache, which usually lives in a node modules folder, .cache, could even be configured if wanted. However, if that command has already been executed in the past, it doesn't actually re-execute it because there's no point to execute the actual command again. But what nx does on this, instead, is restore that cache output and visualize it in your console CLI. So in that case, for a test run, you would actually see just like the actual output with some small note that this has been like taken out of the cache. But this doesn't only work for like printing the output on CI, like on your CLI, but also for processes like the build, where you actually create artifacts that are being like placed, like actual JavaScript files, which are being placed into this folder, they would also be restored. And so if we take now into account these caching features, what we observe is we can even speed up things even more. Because now we don't even just run them in parallel, but it might happen that we have executed those commands before. So in our like local execution of the test runs, we might already have executed certain libraries. And so the caching, like a computation cache, would actually deal with that and not execute those commands again. And so we can even reduce them based on what we executed in the past. It gets even more interesting if we now distribute that, because as we have said just now, what happens is that those caching results are just local to each developer. And so they are locally in your node modules folder, and you can benefit from what you executed, but you cannot really benefit from what your teammate executed. And so this gets much more powerful if we wire in NX Cloud. And so what NX Cloud does is actually it takes your local cache and it synchronizes it to a central location in the cloud. And so basically, if I'm a developer on a team and I executed like a couple of tests on our project, like I use one of those affected commands to run all of the tests of a feature branch. And so basically in that case, these are being cached, they're being uploaded to NX Cloud. If my teammate now comes into work and just like boots up the application, like the NX workspace, executes again also test run, which happens to overlap with some of the tests that I've been executed, those wouldn't be executed again, but they would simply be taken down from NX Cloud into the local cache and then restored from there. And so you can imagine that this already speeds up things a lot in your development team. More interesting, it gets even when you also wire in the CI server. Because like, as we have seen in the picture we've seen before, like one of the bottlenecks is often the CI server. And the reason is that it executes a lot of different kind of building, linting, and test runs. And so it's also able to not only leverage existing runs, which maybe like developers have executed before locally, but it's also able to produce a lot of cached results, which then developer can benefit while they develop on features on their own machines. And so in general, like this idea behind the computation cache is that the duration of the invoked operations should only be proportional to actually what you changed. So you shouldn't basically, as you grow, your build time should more or less be constant, because like you should always only really have to build what you changed and what you touched. And so if you take all those different things into account again now, we can see that we can even get better results with just with now the online NX Cloud distributed cache compared to what we had before with just a local cache. Because obviously now I benefit from the caching I produce, but also what the CI server might have produced or my teammates. And so times get even smaller, get even faster. But there's another open part, like what about NX Serve? And now here we are really talking about super large monorepos, like where you have like an application with like hundreds of libraries where an NX Serve might take minutes, right? Up to 5 minutes maybe. And so 5 minutes is really a long time if you have to start up the application. Like as you run it, Webpack does some work behind the scenes, obviously, in caching and things like that. So like incremental building, as you change things, like as you change some files, it might be faster. But if for some reason you have to restart Webpack again, you again have to wait 5 minutes, which is a super long time. So what can we do about NX-Serve? And this is where the whole concept of incrementality comes into play. So what happens? Usually when we build an application, we actually execute NX build or NX serve at the top level application part. Now in NX, all the libraries are usually not libraries that are intended to be published, like built and published to NPM somewhere, but rather they're just linked into the application. And so what happens is these are plain imports. And so whenever we execute NX build or NX serve application, it just basically links those libraries and builds them into one single build of the application. So we don't really have an incrementality there. Now, what we did, or what our plans are for NX11, is to actually have incremental builds. And these are basically the plans which you have publicly online. So you can go through the NX the repository under the issues. This is a pinned issue about our roadmap for NX11 and ongoing. And incremental builds is one of those. So what does that mean? First of all, what we had to change, or how we had to adapt NX, is we needed to have buildable libraries. So not just like plain normal libraries, but we wanted to have the library also as a buildable target. And so what we introduced already like a couple of versions ago is the -- buildable flag, which is kind of different than the publishable flag, as it does not as much as the publishable builder, but it does a bit less in an optimized way because it needs to be fast. And so you can generate a library with that buildable flag. And what that allows us to do is to actually build those parts independently. So as a result, what happens now is that whenever we execute NX build app, what it does, it is actually going to build all those libraries before. And for being able to do that, we actually need that with dependencies flag as well, which is another addition which we added. Because otherwise, if we just execute an NX build my app, then actually what would happen is it would just build that application, or it would even fail because some of its dependencies haven't been built. Now, the with dependencies flag leverages again the dependency graph behind the scenes. It walks down the tree, and what it does is it starts to build the lowest level node of that tree. And so in this case, for instance, it would go to the shared, it would actually execute a build against it. But at that point, again, NX Cloud or the local computation cache would jump in and say this is already cached because someone else built it already. And similarly, you might have with core, with courses. With sales, we actually have to build it because we might have made a change in our feature request, or someone else, it simply hasn't been built yet. And similarly with the coupons, it is also cached. And so now you can see how this already improves the build performance a lot, because we have really just to build one single sales library in this case. And this is actually what the whole incremental builds concept is about. And so if you look at some statistics here, is what you can see here is this is just a normal build. This is what you would have nowadays with an Angular CLI build or an NX build, where you just execute NX build, right? And so the blue one basically tells you the time that is needed in a large repository to just build application. And so here we are around 68 seconds. A serve is similar. It is a bit more optimized because it doesn't do that much probably. So it's 62 seconds. And the file change is pretty acceptable in this example repository which we created. So it's around 6 seconds. Now, if we compare it to an incremental build, but without having any caching in place, because it's the first time ever which we executed, then it takes slightly longer. And the reason here is mostly because we actually have to go through all the libraries. We have to rebuild them. And for Angular, we use ng-packager. And so that takes a bit more than just linking them together and actually building with Webpack. The interesting part, however, is that a cold repository where you don't have any cache is not super realistic, right? So at some point, either the CI server or some teammate might have already built it. And so these are the numbers which you get from a warm cache. So you can see the NX build just takes 6 seconds because it has already built the libraries, they're already in place. So it just goes ahead and just restores them from the cloud cache. And NX serve takes 7 seconds, so pretty similar. Also an incremental build, you change some file, some component and rebuild it, takes another 7 seconds. So you can see this speeds up things a lot and makes working much more pleasant, obviously, in super large repositories. And so if you're curious about this and you want to play around with it, we have a repository on our Nrwl GitHub account, which is like the NX incremental large repo. So you can go there. There's a README that explains like how to download the repository, how to bootstrap it, and what actually you can find there. And so just to kind of conclude, like what is the status about this and what's next? So what we did with incremental building in NX over the last couple of weeks and months is, first of all, we use now a builder which is based on ng packager, but it is kind of faster because we don't do, like, for instance, UMD bundling and minification, because like in an incremental build, it's not really needed, since we don't intend to publish that package, but just use it as an intermediate part for the application build. We also created a custom builder to work like for the application builds that rewrites the TS path, like TypeScript mapping paths. That's needed because now it basically needs to not point to the actual source code, but to the pre-built library once that has been built. And also we added a simple NX serve command, because like now we don't use Webpack for serving during development, but it's kind of a custom setup that watches the actual pre-built artifact and instantiates it from there. As a point that we are like going onwards, like going ahead from now, we will definitely investigate into speeding up things even more. We might even invest like into how we can speed up Webpack, or whether we can actually use some alternative for those incremental servings and in incremental builds. So thanks a lot. If there are questions, definitely also reach out to me on Twitter or connect with me on Twitter and write me a DMs, like my DMs are open, or just visit our company Nrwl.io Twitter account or our website. Thanks a lot.